Here we will talk about a Python program of shallow copy and deep copy. This helps us understand process address space and the difference between shallow copy and deep copy. To explain these differences, let's look at an example. Suppose you have a notebook with multiple sections. At front, there is a table of contents, and each section is filled with detailed notes. Now imagine you are asked to make a photocopy of this notebook, but instead of copying the actual content, you only copy the table of contents. Your friend receives this photocopy and has to refer back to your original notebook to check out a specific chapter. If they make any changes to the notes in a section, they are actually changing your original notebook. This is how shallow copy works in Python. To understand deep copy, imagine instead of just photocopying the table of contents, you photocopy the entire notebook. Your friend will have a complete copy of every note you made. When they make changes to their notebook, your original notebook stays the same. This is how deep copy works. Deep copy creates a full duplicate of everything, not just the outer structure. Let's relate this to process address space. Think your notebook as memory space for a program. In a shallow copy situation, two processes share certain parts of memory like two people sharing a table of contents but still referencing the same original data. But in deep copy scenario, each process gets its own independent memory space. This isolation is critical because you do not waste one process to accidentally mess with another's memory. Just like how you do not want someone editing your notes when you have given them their own copy. This slide is representing the shallow copy example. There are two tables, one is original and second is copied, but they both are using same items. If we change one item, it will affect both the tables. This is the code of Python where we created a list and make a shallow copy of it, and checking the address of list and its object. In the next slide, we can see the address of list and its object, where the address is different of the list 1 and list 2, but the address of objects of list 1 and list 2 is remaining the same before the updating value and after the updating value. In previous slides, we covered shallow copy. Here we will see example of deep copy. The difference is that both tables have their own items. If we make changes to one item, it will not affect the other table. Here we are making a deep copy of list 1 and checking address of both lists and address of its object. In the next slide, we can see object of list 1 and second, address of list and address of objects. All the addresses are different from each other. If we change any value of the list 1, it will not affect the list 2. So here we will write the code of shallow copy and deep copy. So firstly, I will import a copy module of Python. After it, I will create a list and insert some values. Now I'm going to create a shallow copy of it. To make a shallow copy of list 1, I will write here list 2 and I will use the copy module to make a shallow copy of it. Copy.copy and here I will pass list 1. In the next, I will print our list 2 to check that our list is copied into list 2 or not. It created a shallow copy or not. So we can see we made a shallow copy of list 1 and it is stored into list 2. Now I'm going to print address of list 1 and list 2. Print address of list 1 and list 2. Print address of list 2. For printing our address of list 1 and list 2, I will use id command. id command just used to print The address of the elements or variables, they, in the memory they are stored. And here I will pass list 1, and here I will pass id command and list 2. We will get the address of list 1 and list 2 where the our list first and second stored in memory. So we got the output, and the output is different. Our list 1 is stored in somewhere else, and list second is stored somewhere else. But what if I print the address of element 1? So I'm going to print the address of index value 0 in list 1. Address of list 1 index value 0. Index value 0 means we are starting from 1 and go to until the end. List 1, and here I will pass the index value 0. Index value. We will get the address of element 1, which is here, and the index value of it is 0. So we got the output. The address of both the elements are same. But now I'm going to update our list 2 to check that it will affect our list 1 or not. Because as we talked in our slides, whenever we change in the copied list, it will affect our original list too. So here I'm going to assign a new value on the index value of 0. I'm going to update it with the 8. But now the address is changed here. The address of the element first of the list 1 and the element of the first of the list 2. The address of the both items is changed now. And our list 2 is the updated here, but the list 1 is remaining the same as the previous. So for it, I'm going to add a nested list here. I created a nested list, and now I'm going to firstly print. I'm going to print a new value that I inserted that is on the position of index value 4. I'm going to print it list 2 index value 4 at the position of 1. Means I will printing 78 here, and we got the output. But our actual the thing is that we want to know about it, cello copy change the original data or not, because as we learned it that and whenever we update a new thing with the copied list, it affect our original list also. To check that, we are going to make a new code here. I'm going to assign a new value that will be 0. And again, I'm going to print the address, print the list, print the list 2 and its address also. So here I will pass the index 4 at the position 0, index 4 and at the position, sorry, I made a mistake. Here I passed 1. So now our list 1 and 2 both updated. Means when I assigned a new value in list 2, it affect our list 1 also. And the address of both items are same now. So this is the cello copy. When we make any changes in it, it affect our original list also. So now I'm going to create deep copy of it. Now we are going to see the example of deep copy. List2 copy dot. To make the deep copy of list1, I will use deep copy here and pass list1. Going to print list2. We made a copy of list1, that is the deep copy. And how will you come to know about it? This is the deep copy or not? As like that, we did in our last thing, like the last code, we did something. We will do the same thing in this code. List1, going to print the address of list, address of list1, ID, list1. Again, I will write this code to check the address of list2. Okay, the address of the list1 and list2 is the different, and in the shallow copy it was different also. But now I'm going to assign a new value on the position of the on the index value of 4 at the position of 1. So list2 index value 4 and position value 1 means 78. Our value 78 will be updated. I'm going to update with 0. Here I'm going to print address of element of list 1. Here we can write our index value also, ID list 1. Okay. So now I'm going to print our address of the 78 value. I made some mistake. I'm correcting that. Wait for a minute. Okay. I'm going to print the address of our element of the list 1 and list 2, and going to print the list 1 and list 2 also and address of it. And going to check that it will be update our original list or not. So here we can see our list 2 here, that is the updated with the new value. But our list 1, the original list is remaining the same. There is no effect in it. The last previous value is the same on that place. So this is the difference between deep copy and shallow copy.